Today's problem, find the longest string, difficulty medium. Given an array of strings, find the longest string in the array such that every prefix of it is also present in the array. Okay, probably need an example for that. If multiple strings have the same maximum length, return the lexicographically smallest one. All right. This one's a little bit more complicated. I don't know. Maybe we can sketch this one out. But so this one here, A, B, C, and A, B, D. Now both of those, everything is a prefix in the array. So A is in the array, A, B is in the array. And then we get to ABC, ABD, but all of their prefixes are in the array, and then we would return ABC because it is lexicographically smaller than ABD. Length of the array somewhere between 1 and 10 to the third, 1,000, and length of the strings is somewhere between 1 and 1,000 as well. Expected complexities, n times the max of the maximum string size in the array. So the max would be 1,000 times 1,000, 1,000,000 operations. So that's very manageable. Company tags, Flipkart. I gotta look that up. Flipkart. I keep seeing it, but I don't know what it is. String tags. Well, this is the key one here, the trie, T-R-I-E, pronounced trie. Trie, also known as a prefix tree, is an excellent data structure for finding strings based on their prefixes, and hence is a very good choice for this problem. We're not really going to go into the implementation of a trie. You can look that up once you've done it once. Maybe just save it somewhere so anytime you need it, you can reuse it. The implementations, methods, everything is they're very very similar from one implementation to the next. So just find one you like and keep using it. All right, so let me get a pen here. All right, so a trie, it's like a tree. It needs a root. So here we'll just call this the root of the tree. Now let's go through this example here, the first example. All right, so the first letter is P. I just noticed it doesn't say that these will all be lowercase letters. if not, we're going to have a problem. But all right, so R, we're going to put, and then we'll put the first string in the tree. The first string is P. Now, there's another thing that you do in a trie, and that is if a node represents the end of a word, you mark it, flag it as the end of a word. How are we going to do that here? Let's just circle it. Okay. So we have a P, and it is the end of a word. The next word is PR. Now the P is already in there, so let's just go ahead and add an R. The R is also the end of a word, PR. Okay. Next, PRO. We have the P, we have the R. We're going to add the O. It represents the end of a word, so we'll circle it. P-R-O-B-L, P-R-O. All right, P-R-O. I'm going to put this because we're going to branch this off in more than one direction. But all right, so then we'll add a B here, and we will add an L. L. Okay, now L is the end of a word. B is not. Okay. And the next string is problem, and we have P-R-O-B-L. I mean, the way this works is that trie will have an insert method, and you can put problem in there. It's going to just check it one by one and see what's already there. It'll say, oh, we already have P-R-O-B-L, so but we don't have E. There's no E coming after the L, so let's add that. There's an E after the L. That is not the end of a word. There's an M after the E, and that is the end of a word. All right, what is the next? Pros, P-R-O-S, P-R-O, and then we'll add an S. It is the end of a word, so we will tag it accordingly. Each one of these letters, by the way, is represented by a node. What's in the node is a 26 element array, because you want to be able to hook any of 26 letters onto that node, and also a flag, whether or not it's the end of a word. The next is process. So we'll insert the P, it's already there. Insert the R, it's already there. It's the O, it's already there. C. Okay, well, we need a C. So, all right, so let's insert that. C. Not the end of a word, though. Then E. Then S. And then another S, which is the end of a word. So we'll mark it. Next, processor. Well, we have P-R-O-C-E-S-S-O and R, which is the end of a word. All right, so now we've loaded all the strings into the trie. The next thing is we go through them again, check each word, and see if all of its prefixes are in the trie. And as we're doing that, also keep track of what is the longest trie that we see. So if we try this with P, it's there. So that is a potential candidate. It has a length of 1. The next string is PR. And every prefix should be tagged as an end of word. That's how we know it's a prefix in the tree. PR, that is a string, and all the prefixes are in there. So we have found one with a length of 2. That is PR. PRO, PRO. Each prefix is represented. We now have a length of 3. P-R-O-B-L, P-R-O-B. All right, so we have to stop there because P-R-O-B is not a prefix. All right, same thing with problem. Once we hit the B, that's not a prefix. We can't use it. Pros, P-R-O-S. Everything is a prefix. Longest string now is 4. Process, P-R-O-C. Well, we have to stop there. That is not a prefix. Same thing with processor. And so, as noted here, pros is the longest word with all the prefixes in the array. All right, let's take that down and look at an implementation. Okay. I'm going to scoot this over and try pasting the code here. All right. What do we have? I'm going to take a quick look at there's a couple of new classes. One is a node. As I said, a node has, when we initialize it, it's going to have a 26 it's going to have a 26 element array, and each of those representing a letter. Okay, so we can put new nodes, anything from A to Z, into this node to create children of the node, and then we have the end of word indicator. Now a trie just starts out with a node. We are able to insert into the trie. We are able, well, this is kind of a custom thing here. Check if all prefix exists. Actually, let me say a little bit more about the insert. If we're going to insert a word in the trie, we start at the root, and then for every character in the word, we're going to see does the character, well, get the character. Does the character exist in the current node? Is it a child of the current node? If it's not, then add it as a child of the current node. At that point, it will be a child of the current node, whether we added it or whether it was there already, and then we will get it, move on to the next letter, and continue adding letters in that fashion until we get to the end of the word, and then we will set the set end, meaning we have a set end method here, meaning we will set end of word to true. All right, now this one, check if all the prefixes exist. We have a word that comes in, and we're going to run this as the length of the word, or until we hit, or well, as long as we have not hit the end of the word and end of word is true. End of word has to be true the whole way, meaning that everything leading up to it is a prefix. All right, get a character if the node contains the character. Get the node. Make sure that end of word equals end of word and is node. Now I'm not sure exactly why I coded it that way, but in any case, what we're doing here is if the node does not contain the character that we're looking for, then we're going to return false. If the node contains the character, but it's not the end of a word, in other words, it doesn't exist as a prefix in the array, we're going to set end of word to false. And so that will drop us out of the for loop and will return end of word. Okay. Here is the main routine. Let's see, try, that should be over a little bit. So for every word in the array, we will insert it in the trie. Longest string is initially empty. Now for every word in the array, we are going to check if all prefixes exist for that word. If they do, we'll check and see if the length of the word is greater than the longest length, or if the length of the word is equal to the longest length and it is lexicographically smaller, in which case we set longest to word. Okay, once we loop through everything, we've got the longest word and we return it. Let's try running this. So let me do a compile and run sanity check. Okay. Okay. Yeah, so when you have problems with string prefixes, think about whether or not a trie would help you with that. I guess that's the key takeaway here. And go ahead, like the video, subscribe. You'll get problem of the day in your inbox, and we'll see you next time.